if so, they say consider the circuit below, and you can see we have our circuit with a cell with our voltage, our ammeter, like, and these resistors and all these things. So we have our questions, and yeah, like they say determine the readings on the following meters: V1, V2, and A1. So basically, what's gonna happen is that, do you remember those notes I gave you about like circuits and all those things? Because what we're gonna apply here, as you can see, these are all 1 mark questions. It's that information that I gave you.
Yes, I
So,
do remember.
so you remember like what I said about like resistors in series, resistors in parallel. So how can we do this? For this one, I'm gonna help you through it, and I'm gonna try my best to explain how I get my answers. And then afterwards, we're just gonna try to get a similar question, and we're gonna do it because today I want us to like fully focus on electric circuits. And on Saturday, we're gonna track back a bit, go back to longitudinal waves, and then after we do longitudinal waves, we're gonna go forward, do magnets, and then we're gonna track back again to do transverse waves. I think that will be enough time since you're writing. You said you're writing on the 24th. No, that's when I'm writing. Sorry. So we're gonna have like 1, 2, 3, 4 lessons. So
I write on the 23rd.
on the 23rd, yeah. 1, 2, and 3. So 3 lessons, including today's lesson. And also, another thing is that I know, like, obviously on the 21st, you won't be like fully ready for your exam. What I suggest is that on the 22nd, if you have like, if you went through like question papers and you find something that you don't understand, or something that you're gonna need help with, on the 22nd, we can make arrangements to meet. I can help you with all those questions that you don't understand, just in preparation for your exam. But if you don't have any questions, then it's fine. But anyway, I think we should get started. So they say consider the circuit below, and they want you to determine the readings on V1, V2, and A1. So first thing we're gonna look at when determining the readings, we're always gonna go to the resistors. So as you can see, R1 and R2 are in parallel. So what that indicates is that remember about parallel resistors, they cut the parallel resistors are current dividers. So the current going through here and the current going through here are different, but the voltage is equal. So what you have is that you're gonna have the same amount of voltage going through R1 and the same amount of voltage going through R2. So that means the reading on this voltmeter, which is 8 voltage, is going to be the same as the reading on this voltmeter V2. So just from that, we already know that the reading on V2 is going to be 8 volts because resistors that are in parallel, they divide the current, but the voltage going through them is equal regardless of the resistance. So what we're gonna do next is that we have the voltage going through these two resistors. It's 8 volts, and we have the voltage going this through the third resistor, which is 4 volts. And when we look at our circuit, there's no other resistors. So what that means is that the voltage going through R3 added by the voltage going through R2, which is equal to the voltage going through R1, is going to be equal to the voltage that the battery introduces into the circuit, or the EMF, or potential difference, like whichever words you want to use. So you're going to add this 4 with this 8 to get the reading on voltage on V1, because this is the reading for the battery only. So from this, we know that we have a 12-volt battery, and the reading on V1 is going to be 12 volts. Right, now we're going to move to A2. Oh, sorry, A1, which is here. Divider. So now we know that this is going to be an 8-volt reading. So now what we're going to do is that we're going to check for the overall current going through the circuit. And the overall current going through the circuit is 5 amperes, because as you can see, this is not plugged to any resistor, but this one is plugged to R1 and this one is plugged to R2. So basically the reading on A2 is the same as the reading on this ammeter. So what we're gonna do now is that we know that there's 5 amperes of current flowing through the circuit. We're gonna go to, and we know that since these resistors are current dividers, the current going up here is not equal to the current going down here. So these currents are not equal, but the sum of these currents, when you add them together, they're gonna give you 5 amperes. So what you're gonna do is you're gonna take your 5 ampere, subtract your 2 amperes, and you're gonna end up with a 3 ampere reading on A1. Yeah. So are you still with me so far?
Yes.
Okay. So now they tell you that which resistor R1 or R2 will have a higher resistance, and give the reason. So what you're gonna say now is that we're gonna look at Ohm's law. And Ohm's law states that the potential difference between um, two points in a circuit is directly proportional to the current and resistance. So you're gonna end up with V is equal to IR, and I is the current and R is your resistance. So what we're gonna do now is that we are going to make our current, because here we know that these resistors divide the current, but they don't divide the voltage. So if we make voltage the subject of the equation, it's it's useless. I'm not gonna say like it's completely useless, but it's not gonna get us to where we wanna go. So we're gonna take what is being divided. Sorry, let me just unplug this. We're gonna take what is actually being divided, and in this case, it's our current. So we make our current the subject of the formula, and we're gonna look at this equation. If we make our current the subject of the formula, we're gonna divide both sides by the resistance. We're gonna end up with V over R. Uh, yeah. So basically, how we do that, you're gonna say V, you're gonna divide both sides by the resistance, and that's gonna be equal to I divided by R, and this one is gonna cancel out with this one, and you're gonna be left with current. And then if you look at this, you can see that if the current passing through 2 points, and this time we're talking about these, we're going to talk about these 2 points because that's where our resistors are connected, these 2 points. So we're going to talk about the current going up, and we're going to talk about the current going down. So what happens is that the current, if you look at your equation, you know that 1 over 2, that's going to give you 0.5, and then 1 over 4, that's going to give you 0.25. So what that means is that the larger your numerator get, sorry, the larger your denominator gets, the smaller the current is going to be. And in this case, our denominator is resistance. So that means the one with the higher resistance is going to have the lowest current flowing through it. So the resistor with the highest resistance is going to have the lowest amount of current flowing through it. Now we know that the current flowing through R2 is 2 amperes. And from our previous question, we found out that the current going through R1 is 3 amperes. So the one with the lowest current has the highest resistance. So what that means is that R2 has a higher resistance than R1. Do you understand that?
Yes.
Because I just tell me if I lose you. That's why I'm trying to like be very, very specific. And then now, like, I'm pretty sure you heard the reason. The main reason, so for this answer, your answer is gonna be R2 has the higher resistance, and the reason is because there is a lower amount of current flowing through R2 than in R1. That's your reason. And then now we're gonna go to third one. They say calculate the quantity of charge that passes through R3 in 2 minutes. So this is actually an equation that I I don't think I introduced you to this equation, but maybe they did introduce you to this equation in class, and then I just didn't. So there's this equation, the equation for current. So what you should know is that current is equal to the rate of change in charge, which means current is equal to the charge, in which we just got we stated as Q divided by the time. So that's another equation for current other than the one we get from Ohm's law. So I think you should keep this equation. Maybe you can write it down somewhere, because you're most likely not gonna receive this equation in your question papers, but they will want you to apply this equation. Let me just check on this question paper. Yeah, no, they don't give you the formula. So please just write this equation down. It's very important for circuits. And now let's go forward. Put this over there. Yeah. And now they want you to calculate the amount of charge passing through R3 in 2 minutes. So on R3, the amount of charge flowing through R3, sorry, the amount of current flowing through R3 is the total current of the circuit. It's 5 amperes because it's not in parallel with any other resistor, so the current is not divided by the time it reaches R3. So what we know is that we know our I, which is our current, which is 5 amperes, and we know our time, which is 2 minutes. But since we're doing physics, or since we're doing science, we do not use minutes when we're referring to time. We don't use minutes. We're gonna use seconds. So what that means is that first you have to convert these minutes into seconds. So you're gonna have 2 multiplied by 60 seconds, and then you're gonna have 120 seconds, uh, and that's gonna be our time, which is 120 seconds. And now, since we have all these, what we can actually do now, we can make Q the subject of the formula. So in order to do that, we're just gonna go in. We have, I'm just gonna write it this side. I is equal to Q over T. And we use small letter t for time and big letter T for period. Keep that in mind as well. So this is over 1. So these are gonna cross multiply. This is gonna take that. This is gonna take the 1. Yeah, you cross multiply everything. You're gonna end up with Q is equal to the current multiplied by the time, and then we're gonna end up with Q is equal to 5 amperes multiplied by 120. And our charge is gonna be 5 multiplied by 120. I think that's 600. Yeah, that's probably 600. The where's my calculator now? Is it 600? I think it's 600, right? 5 times 120, 600. So our answer for the charge is 600. And the unit, the SI unit for charge is coulombs. So what we're gonna have here is our charge being 600, 600 coulombs. So that's the amount of charge passing through our tray. And now they say calculate the work done by the quantity of charge through our tray in 2 minutes. Okay, so let me just do this because now they're just like throwing all these new things at you. Um, so so um Kota, just from curiosity, have you guys learned how to like calculate the charge and the work and stuff like that?
Yes.
So you did learn this in class.
Yeah.
Okay. So which formula did they give you guys for work?
We do Q equals I. Then I'm not sure what the triangle is. Then the T. Do you understand what I mean?
I think the work is equal to Q. Is it? Isn't it like? Isn't
Can
it?
I write it down quick?
Uh, yeah, you can send it to me, but I think it's usually
Okay.
Q is equal W is equal to QV, isn't it right?
No, I said Q equals I triangle T.
Oh, no, that's this one
Okay.
equation because yeah, like you put the triangle here and the triangle here. So what this triangle actually means, huh? Whenever you see this triangle, we call it delta, and what delta means to us is that whatever quantity we have, let's say let me use delta t for example, nah? Whatever quantity we have, we're going to take the final value of that sorry, whatever unit we have, we're going to take the final and we're going to subtract the initial. So if you ever see delta in front of like time, in front of x, in front of whatever, what that means is that you're going to take the final and you're going to subtract the initial. So obviously delta q is going to be q final minus q initial. But the reason why we don't usually write it like this is because usually the initial is 0. So that's why we just write q over t. So for work, there's this equation that states that work done by a circuit is equal to the charge. What's wrong with this mouse now? Is going to be equal to the charge multiplied by the voltage. Have you seen this one?
I can't see.
Uh, should I highlight it in red? I don't know. Can you see it now?
W equal Q.
QV.
QV.
Yeah.
No, I don't think so.
But they ask you a question about it. So just know that the work. You can also note this one down. The work done in a circuit is equal to the charge multiplied by the voltage. So, not exactly in a circuit, but at a particular point or on a resistor or between 2 points, you know. So they say the work done by the charge that passes through R3. So what we know is that passing through R3, there's 4 voltage, and the charge going through R3 is 600 coulombs. And the work is the product of the voltage multiplied by the coulomb, by the charge. So what we're gonna have is gonna end up with W is equal to 600 coulombs, 600 multiplied by 4. Four times 600, that's gonna be 2400. So you're gonna end up with 2400 joules. Since work is energy, we're gonna use the unit joules, and
Excuse me?
work is energy.
I actually remember this one is the equation thing.
Okay. So work is energy, we're gonna leave it in the form of joules. Charge is a charge, we're gonna leave it in the form of coulombs. This is the same charge that we use in electrostatics, so it's still gonna have the SI unit of coulombs. So so far, are you still with me, or like did I lose you somewhere?
Now I understand.
Okay, so since we have like 5 minutes left on the clock, I'm gonna end this meeting. We're gonna start another one, and then maybe we can look for another question based on electric circuits. Okay.
Yes.